Hello, we are looking at a math problem that calculates the number of milligrams of a medication in a person's system, which is M, after T hours after it is given. So up here we have our function M, number of milligrams based on time after it was given, is equal to this formula. The first question that we're asked is what was the initial dose of medication? So initial means that at time 0, at the beginning. So because the time is 0, we're going to plug a T into this equation. So we're finding the medication when time is 0 using our function notation, and that's equal to 20 e to the negative 0.4 and times 0. So we're going to just go to our calculator and type this and find our answer. So in my calculator, I start by typing 20. I use the keystrokes of the second and the ln button to get e to the. Depending on the model of your calculator, this is going to start with a parenthesis. Here I have the smaller font, and I type my exponent, which was a negative 0.4 times 0, and hit enter, and I get my answer of 20. So very straightforward, just typing with the E on the calculator. And so we get our value here, and our value here is indeed 20. All right, so let's look at the next question. How much will remain in their system 5 hours after the initial dose? Write this problem and solution in function notation. Well, we're asked about 5 hours. 5 hours is a time, so we're putting that into our formula for T. So very similar to the problem we just did. The amount of medication in milligrams 5 hours after the dose is equal to 20 e, exponent this time is negative 0.4 times 5. All right, going back to my calculator to type this in. So I type 20, I use second and the ln key to get the e. My exponent is negative 0.4 times 5. We hit enter, and we're down to 2.7, and we can choose how to round, so 2.7, 2.71 milligrams. So we see that the body has eliminated a significant portion of the initial dose. So writing my answer, this is equal to 2.7. And the label here would be milligrams. All right, so question 3. Ask me this time how many hours will it take to be only 5 milligrams? So this question is very different than the first two. In the first two, it gave me the time, and I could substitute that into the formula. This time, the 5 is not the time, but the 5 is the milligrams. So when I look at the formula, this M of T is the milligrams based on time, and so this time my 5 is replacing the M of T. So I'm going to write out M of T instead of that is 5. I want the milligrams to be 5, equals 20 e to the negative 0.4 t. Now, I have what is considered a nonlinear equation. This is not a first-order equation. It's actually called an exponential equation because my variable is part of the exponent. Solving an exponential equation by hand involves more difficult algebra than solving a linear equation. And so we're going to use a feature of our graphing calculator to come up with a solution without doing the algebra by hand. And so the first method that we're going to use is called crossing graphs. And we recognize that when we type something as a y equals, our calculator will show us the graph. And so when we graph two different y equals functions, they will most often intersect, and where they intersect, they would both be equal. So what I'm going to do in my calculator is I'm going to make this side of the equation my y1, and I'm going to make this entire side of the equation y2. So going to my calculator, I want to type the equation. So I go into my y equals. In my y1, we said we would make that 5 because that was the left-hand side of the equation, using my arrow key to go down to y2. And y2 is what will make 20. And then we have to get that e with an exponent of negative 0.4. And then we had our variable t. On our calculators, the variable button is here beside the alpha key, and our variable will be x because we're using the coordinate plane to graph. So once we have these typed in, we need to get a sense of what size window. So we have to think about the answers that we got before. So I'm going to go to my window. My x represented my time. It does not make sense to have time less than 0 because 0 was when the medication was initially given. And we saw that the medication was down to 2.7 milligrams in just 5 hours, so I don't think I need to go past 5. In the y direction, y represents the milligrams. It doesn't make sense to have less than 0 milligrams, so I'll let that to be 0. As far as y maximum, we saw that the initial dose of medication was 20, so it doesn't make sense to go above 20. So I'm putting these numbers in from the context of the problem. Had I not done steps A and B of this problem, I could have looked in my table to get a sense of the values. Now that I've set up my window, I'm ready to graph, so I will hit graph. And I see these two intersecting lines. So this first line is where y equals 5, right here. And the second line is that formula, the 20 times e to the negative 0.4x. I can see that those two will be equal right here, where they intersect, and my calculator will find that point for me. So whenever I want my calculator to do some math, I have to use this calculate menu up here. It's written in blue, so I'm going to get there by using the second and then the trace button. I want it to calculate where those two functions intersect. So I'm going to move down here to option number 5. I'm using my arrow key to get down there. Hit enter. And it asks me some questions which I do have to answer. So the first question, is this my first curve? And yes, the cursor is blinking on the first line that I entered. So enter. I see my cursor is moved. It's asking me, is this the second curve? Again, I hit enter. Those are the two that I want to use. Now it asks for a guess. You don't have to guess, but it typically is a good choice because sometimes, depending on the curve, there would be more than one point of intersection. So I move this very close to that point where they meet, and I hit enter. And I get my answer that in approximately 3.5 hours, the person's milligrams of the medication will be down to 5. So going back to my PowerPoint, how many hours will it take? It will take 3.5 hours. Get my decimal to show up there. And we found that answer by the crossing graph method. Our last question here asks us to redo question 3 using the zero method. So on the zero method, we take this exact same formula that we had here, and we get one side equal to 0. And we'll do that by subtracting. So I'll subtract 5 from both sides. So I have 0 is equal to 20 e to the negative 0.4t and minus 5 because I had to subtract 5 to move it over to the other side. So I'm going to go to my calculator with this information and use a little bit different feature on my calculator to find the answer. Here I am back at my calculator. Again, I'm going to y equals. This time I'm going to clear what I had previously. And I'll put this into y1. So my equation was 20 e to And now if you have a TI-83 or an early TI-84, you have to use the parentheses here and get that right, or this will not work. So I'm going to type my parentheses so that you can see where they would be. Negative 0.4x, and then that's the end of my exponent. So I have to get out of the exponent and then type minus 5, because we subtracted 5 to make it equal to 0. I'm going to set up my window. This time on my window, because of that minus 5, it is legitimate to go below 0. So I typically will make, so x is not going to go below 0, time will not go below 0, but the y value could go below 0. And so we put a minus 5 there, so I'm going to make that y minimum be negative 5. Negative 5. Okay? Because of that minus 5, it seems legitimate that we could go down 5 additional spaces. So then I hit graph, and you see my line, and you see it cross the x-axis right here. Where it crosses the x-axis is called a 0. And that is the point I want to find, because back in my formula, I had it equal to 0. So in order to find that, I want my calculator to do some calculations. So second trace. In my calculate menu, the second option is to find a 0. So I go to that second option, and it will ask me questions. And the questions here are a little bit different. Again, you do have to answer them for this to work. The first thing it asks me is a left boundary. This means that I have to have my cursor to the physical left of where I see my 0. So my cursor is there. I'm going to hit enter. Now on this model, it draws me a little line. On some of the older models, you won't have that line. You'll just have the little arrow. Now it asks me for the right boundary, and that means I physically have to move my cursor to the right of my 0. So using my arrow key, moving over quite a bit until I am to the physical right of where I see that 0. So that looks good. I probably went a little too far, but I'll hit enter. Then it asks me to guess. This is similar with the intersect method, so I move back closer to where my 0 is, hit enter, and you see that it calculates that 0, and it is the exact same answer that we got before, so it is that at 3.5 hours, the value of this function with the minus 5 has gone down to 0. So on my PowerPoint, when I solve this, I also get that 3.5 hours. Now, the two methods gave us the exact same answer, and so you may be wondering, like, why do we learn both? What is the value? Both work all the time. Finding zeros is helpful with certain types of equations. Polynomial equations are it's very helpful to find zeros. For me personally, I prefer this intersection method because I don't have to do this extra step of algebra, and I just use y1, y2, and find the intersection. Rather than this extra algebra, I feel like I'm making my calculator do all the work.